Okay, so, and I will share my screen. Perfect. So welcome. This is a debugging workshop, and my hope for today is to kind of help you get your feet on the ground so that you can avoid sort of banging your head against the wall with certain problems. To some degree, that's inevitable. In a large part, in many respects, debugging is a skill that you develop over time. So often you're going to be finding yourself in difficult situations that don't make any sense, and you're going to just be having a really tough time, and just nothing works, and it's awful. And the key thing is just to keep going and to try to think carefully and make some key strategic decisions in advance of even starting to code that will help you have an easier time of it, right? So it's not going to be easy. It never is, but there are certain things you can do to kind of make your life a little bit easier. And the first thing is to make sure that you're, and I know this sounds sort of silly in some sense, but you want to make sure that your system setup is correct, right? You need all this stuff installed. You need to be able to run your tests, et cetera, et cetera. Now for this course, right, we're suggesting the use of the unit testing framework. I happen to write that framework, so and I'm constantly maintaining it. So if you have any questions about it, you can ask now or at any time, either here or on Piazza. We're happy to answer them. Recently, I've actually been making a few updates to the extension. There were, believe it or not, a few bugs which were hampering people's ability to do some work. I'm sorry about that. But you should install this extension. If you don't, have your VS Code set up and all this kind of stuff, please just do that. Take the time, take a couple hours to get that done. And once the extension itself is set up, having a good sense of how to use it is the next thing, right? Like any tool, it requires a little bit of getting used to. And in this case, like, we're not using main.cpp, you're not running make, you're not running Valgrind, but all those things are happening for you basically in the back end. So, right, getting your stuff set up. The next thing is to sort of establish your workflow, right? And I actually wrote a little, let's see. Oh, okay, all right. Well, share my other screen. Oh, well.
Hi, I was having a lot of trouble setting up the unit test. I was wondering if you could run through that really fast or come back to it later.
Sure.
If that's not something that would help other people.
Yeah, I can like quickly walk through it.
Yeah.
So first of all, the one thing I want to ask is, did you have it set up and then it like wasn't running? It wasn't running the test, so like couldn't add something. Were you having this kind of bug?
I just was having trouble setting it up. When I was doing the first lab.
Okay. Well, how about this? How about I sort of walk through what I would do if I was starting the lab, and that way we can all kind of be on the same page. We're working with code that we should all have, and we go from there. Sound good?
Yeah.
Okay, cool. So I will share this other screen. Oh, but it's going to wind up. Well, that's okay. I'm going to have to keep doing different screen shares, but we'll be just fine. Let's see. I want to be here. No, here. Okay, so right, and to this end, let's go here. We'll go to lab 1. Okay, we'll copy the files, comp 15 files, lab 1, star here. Okay. So when you're using the unit testing framework and you're using it through the VS Code extension, first thing to remember is that you need to install the extension on the remote system. So I've already SSH'd here using remote SSH. And now I'm in VS Code on the remote system. I'm in homework 3 on Halligan. And I have C++ unit testing framework installed on the remote, not on the local. It needs to be on the remote. And then if you see the update button, please hit that. Please update it. There were 1 or 2 bugs which might have been causing the problems for you that have been taken care of. And the next thing you need to do is to initialize the workspace. So the way that the extension works is the first thing it does is it checks for the presence of a file called unittest.h in your workspace. And one of the kind of weird or not exactly intuitive aspects of VS Code is that when you boot up VS Code, there's this notion of a workspace. And the workspace is the sort of place, well, obviously it's a place where you're working, but it like various applications and extensions like the unit testing framework will be looking for files within that space or being able to manage different things within that space. And essentially the way it works, the backend code of building extensions, you have variables and functions which you can access which relate to workspace stuff. So they make life simpler. And so long story short, you need to initialize the workspace. And the way you do that is code space dot. And this will initialize the workspace. I know I was saying about the screen share. It opens a new screen. I kind of wish it didn't, but that's just the way it is. Share screen. And let's go to this one. Okay. So now I've opened up a new window, and you'll notice on the left here, this is our workspace. This is where we are. Okay. So, and the other thing that you'll notice is this testing panel. If anyone is having trouble with this for your own project or something, the testing panel will only show up if you have a file named unittest.h inside your workspace. Okay. And so hopefully everyone has that. And so now,
when I entered the command code space period, it said command not found. I was doing this on like terminal outside of VS
no,
Code.
it's got to be within VS Code.
Oh, okay, gotcha.
The whole code command is is native to VS Code.
Okay, that was my problem.
Yeah, yeah. I think in Windows, when you install VS Code, you can run code command from like PowerShell, but I don't know if that's true on a Mac. But the code command should open up a VS Code window, and it certainly works within VS Code. But yeah, I don't know about outside. So yeah, so once we're here, let's look at, when we look at our unit test file, we've got various tests and we see our play buttons. So some people were having problems where there were play buttons where there shouldn't have been, or there weren't any play buttons. But as long as you've done the steps that I just mentioned, you should be able to see all of the various functions here, the test functions, and anything that's commented should be commented out. There shouldn't be tests if they're commented out. And actually now that should work for tests. And you'll notice as soon as I uncomment it, we have this, right? So if I can also block comment, this was bugged before. They were both bugged really. So apologies for that, but this should work now if you're using the latest version of the extension. Okay. And the key thing to remember about the way unit test works is that each test is effectively its own main. So the sort of backend details of the framework aren't really relevant here, but when you're writing each test, think of it as its own main. Each test is run separately of all the others in its own process. And the actual main function, basically, the only thing it does is it calls your function. So that's it. And the next thing to think about in terms of, okay, so does that all make sense? Are there any questions so far? If people are working along, is anyone stuck at this point? Or does everyone see this kind of thing? Or not that you have to be working at this point, but if you are working along and you get stuck, let me know.
I don't have the little down arrow when I click on the unit underscore test H, it doesn't bring anything down in
Is
test
there
A.
is there some kind of error message there?
No, there's just nothing there.
And when you go up here, do you see something like this?
Yes.
Okay. And oh, by the way, what we're doing right now is debugging, right? Even though it's not like looking at code, we're trying to get.
Actually, I don't have anything that says open editors.
So, oh, well, if you don't, do you have the file open?
What?
The file unit test.h. So if I close this, it'll go away.
Yeah, I have the file open.
Oh, you do. So did you initialize the workspace with code dot?
Yes. Code space dot, right? And it opened up a new window.
Yep. And then you're working in the new window.
Yes.
And you see all your files on the left.
Yeah.
And when you go to the extensions tab in the remote, do you see this?
Yeah.
Okay. And when you click on it, does it have the ability to update it, or what's the version number there?
V027.
Okay, so that's right. And when you go back to the unit test.h file, do you see any of the play signs?
No.
That's interesting. But you see the testing panel? Like this guy?
Yeah.
And did you just copy the starter code from the lab directory?
I did.
That's interesting. I'm guessing that the workspace for some reason didn't initialize right. So I would suggest closing all the VS Code windows you have, restarting it, and then going to the directory and then running code dot. Oh, when you ran code dot, were you in the folder that you were?
Yeah.
You're working? Okay, so I would try closing all the VS Code windows, reconnecting, trying again, and see if it works. Did you just update the unit test, or had it been updated before?
I just downloaded it, like the one that came up.
Okay.
And that was
so that should be the newest version. But for whatever reason, if you just did it, you might need to restart.
Okay.
I would suggest restarting it, going back, and then let me know. I don't want to spend too much time right now. If we can't figure it out, then later I'll just work with you afterwards. Okay.
Yeah.
Good. And just mention in the chat or whatever. Feel free to just pipe up again when you're ready. Okay. So once things are set up here. Oh, there's another point worth mentioning. Well, actually, we don't have to get into details about it, but the make file we've provided for you for the homework in the labs, you can take a look at. The key point here is that the main of the program lives in a file called unit test driver. And the CPP file that has that main function is compiled for you by the program, but you need to link it with, you need to link the unit test driver.o with your other one. We'll get into the details of linking and separate compilation, et cetera, later on. Today, I'll cover some common errors related to linking versus compilation. But anyway, if you're working on your own, you need a rule that will build this, that will link your code based on the .o file. Okay. So, okay, let's start from scratch. Okay. Let's get rid of all this. And what we're going to do is create a student class. I did this in the intro to C++, but specifically, I wasn't really making many errors on purpose while I was writing it. But the idea now is going to be that I'm going to start to write the code for this stuff, and we're going to bump into errors along the way. And then in the process, I'm going to try to demonstrate what I think is a good workflow, kind of, which is probably the most valuable thing to glean from this. And meanwhile, hopefully I'll be able to parse through some of the errors which might not make sense, and give you some sense of what they mean and why they're there, et cetera, et cetera. But the sort of one or two key points to mention, again, the workflow is the one which I'll get into in a moment. And the other main thing to remember is the compiler is your friend. And this is really hard to internalize, but it's something which is very important to get used to. Basically, the compiler errors are there to help you, and they're there to help fix problems that would be there. But it's really important to just, like, when you get errors, it's okay. But to that end, there are a few different strategies for discovering errors and for solving errors, which are worth the time to internalize. So the first one is that you want to be compiling, running, and testing your code as often as you can. And the suggestion that I would give you is to never write more than 5 or 10 lines of code before you compile. If you're writing like 15, 20, 30 lines of code and not compiling and running and testing your code, you're in deep trouble. And it's something that I know I did when I first started coding. And I find that anytime that I find myself in like deep trouble, it's usually because I have not tested my code early enough. And this is basically why the unit test framework is there. Once you get it installed and like go through all the hassle of just sort of figuring out how to get everything working, which does admittedly take a little bit of time, you can just begin to run tests very, very quickly. And so the goal is to be, when you think about a function that you're going to write, you think about its parameters, why it's there, what it's doing. And then once you have a rough plan about it, oh, I see something in the chat. Close everything, restarted, and it's all there now. Yay. All right. So yeah, just restarting it. The first time install, just a restart will work. Good. So yeah, after you have a basic plan for a function, writing out your function is good, a few lines of code or whatever. And then write tests for that. So let's have an example. And along the way, we'll try to see if we can make some mistakes in our getting things all established and then figure those out. But I hope I'm not too scatterbrained right now, but yeah, so, okay. Compiler is your friend, write a few lines of code, compile and test that quickly. And once you fix the bugs and then test them as best you can, maybe comment your code a little bit and then keep going. Yeah. So, the last thing I want to mention before I dive in, the compiler. Okay, I mentioned before the compiler is your friend, which is great. But the key, the one thing that can be really difficult to understand is that the errors that are usually the most challenging errors to debug are not ones that the compiler catches. And that is when you have logic errors. So if you're doing something wrong that the compiler doesn't catch, but it's still a bug in the way you're thinking about your program, or you're just doing things that you don't expect. And that is often what causes the most problems. So being as clear about the functions you're going to write in advance as possible is a good idea. Of course, you're going to develop your understanding about what's going on as you write the function and as you write a couple functions, how those work together. However, just being clear about exactly what you're trying to do is important. And then being able to test exactly what you have done is important. Often there's this gap between what we think we're doing and what's actually going on the machine. And so to that end, again, writing a few lines of code, writing tests, running the tests. that's sort of the intended workflow that should make things as easy as possible. So I have another message here. Could I explain what a workspace is, right? So the workspace is this VS Code specific, I don't know, it's not an idea, it's a VS Code specific feature. I don't know if it's exactly a feature, but essentially the workspace itself is essentially, it's more or less a folder that you're working in, right? So like normally if you had another, Sublime or whatever, you just open a folder and you can navigate around over here. However, you'll notice that in this Explorer context, I can't really go up a level, right? So my workspace is just a static set of files where I'm working. And if you have more folders in here, you can go down levels, but you can't like double click and open up like from the window here, another workspace. So there's like one workspace that you're working in that is, I mean, I wish I had a better way to explain it, but that's just kind of how it is. Think of it as your current working directory when you're working on a project for this course, like lab 1 in this case, or whatever, or I guess now it's going to be an example or what have you, or homework 1 or whatever. You'll have a folder for where those files go. And then when you open VS Code, you navigate to that folder, then you want to initialize your workspace there. And the thing that's important for unit testing is that the unit testing framework depends on your having initialized the workspace there, because the code it uses the VS Code API, which has workspace-based stuff. So again, you don't have to worry about any of that, but the question was, do we need to open one every time we try to edit? As long as you're using unit test, yes, please do. And the ones we open for, sorry, I guess, we can, please feel free to post the questions in the public chat as opposed to personally to me. But the question is, do we need to open one workspace every time we edit? And are the ones we open for the same directory the same ones? I'm not sure what that means, but if I open a workspace with any folder, it'll open a new directory with a workspace initialized in that folder. Okay. Okay, issue about copying homework files. Missing destination. Yeah, so when you do CP command, the way it's formatted is like this. The source and then the destination. So you have to put space dot, and dot is your current working directory. So when you run this command, wherever the source happens to be is fine, and dot means put it wherever I am now. So that's the key thing. And if you're running CP, by default, CP only copies files, not folders. So if your path to files, then it's not going to copy anything because it thinks you're trying to copy a folder. So you have to do /star, which will select all of the files inside the folder. Alternatively, you could do cp-r, but that will also copy the folder name itself where the files are stored. And then all of the files will be in that folder. So either way is fine. Good. Okay, so that's just CP. But yeah, so let's get into it. Let's get into some writing code and debugging. Okay. So what I'm going to do now is I'm going to plan to make a student class. And the idea behind the student class is very simple. Every student is going to have a name, and maybe they'll have a birth date, and they'll have, I don't know, a GPA, something like that. Okay. So what do we do? So we're going to make 2 files. Oh, and actually I can use just the code command. We'll open those up. So we got a header file and an implementation file. And in the header file, I'm going to start my class. So let's see. And fair warning, my plan now is to, oh yes, this will be recorded. The meeting will be recorded. My plan is to start coding, but I'm going to be purposefully introducing bugs and then catching them when we compile. So that's the goal. And what I'm also going to do is open unit tests. Okay. So remember, unit tests is going to be where we have tests for the various functions that live in the student class. Okay. So the student class is going to have a constructor, right? And let's see, it's going to have, we said, a name. And oh, let's see what happens if we leave that out. It'll have an GPA, and maybe we'll have a birthday stored as a string. Should be fine. So I have the auto formatting turned on, which is described in one of the videos. I can help people with that if they like as well. But this is auto formatting this because I forgot a semicolon there. So now, okay, just to keep the types together, I'll do that, but it doesn't really matter. And then let's throw this, the least important, the GPA. So let's see, I've written 1, 2, 3, 4, 5, roughly 6 lines of code here. And before I even do anything else, I'm just going to try to compile it and see if it works. And yeah, question about using unit testing, and we're going to go right into this. So in my unit tests, I'm going to create a function, void first test. That's a terrible name for a test. That's better. And we'll declare a student object. Okay. So we'll notice once I save, I have the ability to run this. Now, when I hit this button, this magic button, a couple things happen. First of all, your code is compiled. Second of all, the code is run. Thirdly, there's Valgrind that's run on your code. And then the results are demonstrated. So right now the code is being compiled, and there are errors here. So this is the first kind of error that I want to discuss. This kind of unknown type name, or could not find name, or undefined function, or things of that nature. What this is saying, right, and this will get into a small discussion about compilation and linking and what's going on here. So when your code is compiled, I don't know if you were there at the C++ intro, I discussed a little bit about what's happening in compilation. But remember, normally when you compile, it's Clang++. We would have student.cpp, and then you'd have your main, right, as well. But and an executable is produced when you're finished with that, right? In this case, the unit testing framework uses the make file, and we'll run make, and make will run Clang++, goes here, and then these files as well. Although actually I haven't declared this. Technically, pretty sure the compiler will figure it out automatically, or make will figure it out automatically. But the idea is that we're compiling. Okay, so again, to walk back a little bit, when you run Clang++, myCPP1, myCPP2, myCPP3, 2 steps happen. The first is compilation. And compilation is a step where essentially all of the syntax of your various function calls, class declarations, definitions, type checking, all that kind of stuff happens. And the second step, linking, is where you've taken a bunch of compiled files and then you put them together, basically. So this is part of the way you can think about it. The header files declare the various bits of information about your class, right? So the student class, from the header file, you can see it as a constructor. There are various parameters associated with it, or member variables, and great. So in our testing, when we're using that class or testing it or what have you, we can declare instances of the class using the default constructor, right? And when we compile the code, again, normally when we think compile, it's compilation and linking, but what actually is happening is 2 separate things. So when we compile the code, there is checking to make sure that, for instance, there is somewhere defined for you, in this case, a student class and a live transcription, oh, sure, that there's a student class and that it exists somewhere that you can call. So here, this message is saying unknown type name student. And this is because we have not pound include student.h. So without the pound include, there's no, the code here has no knowledge of this other code here. And when the compiler is running, the first thing, or not first thing, but one of the things it's doing is it's checking where is the definition of this thing. And so here it is, right? Now when we pound include, when the code is compiled, what happens in behind the scenes is this is actually copied and pasted here. That's actually what happens. But again, with the compilation, we don't have any of the definitions for these functions, or assuming we'll write more, those will be in the student.cpp. So that's going to be compiled separately. And in the linking phase is when they get put together. So again, the compilation at the beginning, during compilation, the human readable code is turned into object code. And object code still has basic placeholders for the definitions of the functions. So the types are all checked correctly. And however, the definitions aren't put together with the declarations. Okay. So if there are any questions about that, you can post them in the chat and then I'll get to them. But the key point again is that here we haven't done pound include student.h. So now we've pound included it. So let's run it again. And here's a great thing to think about as well. So when you see more errors than you did before, when you fix an error, that's not a bad thing. Usually there were things underlying what was going on. And if you see more errors, that's totally okay. The key thing when you do see compiler errors, don't start at the bottom. With the unit testing framework, it's relatively easy because I think the top is always the top of the error list. But you want to start up high because sometimes the errors down below are cascading from the one up top. So the first thing you want to do is start at the top, work your way down, and don't be. It can be easy to be sort of intimidated by a large wall of text, but actually, first of all, sometimes a large wall of text have to do with one error. So in this, all of this text has to do with this one thing, and it's a pretty simple one. And fortunately, because we're using Clang, we have pretty nice error messages, and this is pretty heinous. But if you look carefully at the first error message, try to really figure out what it's saying. Sometimes they actually give you the answer for what to do in the message. So it's saying unknown type name string. Did you mean std : string? So string is from the standard library, and we need to scope this string. So the other thing to notice is which file the error was on and which line it was on. So this was included in unittest.h on line 1, so that was here. The file, the error itself is from student.h line 7 here. So let's see, okay. Student.h, line 7, right. And we can see we're probably going to have the same issue with birthday. So let's do that. And then let's go back here and run our test again. Okay, let's see. Error, expected semicolon after class. Well, every class has to finish with a semicolon, sure. Notice I haven't done anything in the terminal. I have not run make, I have not run Clang, I have not run Valgrind. I'm only going back here and hitting this one button, which is doing all that for me. Error, calling a private constructor of class student. What's that going on? So every class, remember, has to have public and private member functions and variables. And we need, things are private by default. We have to mention public here, private here. Again, all of these errors so far have basically told us exactly what's going on. Implicitly declared private. Okay. All right. Okay. No role needed to make target student needed by student.o. Why are so many spaces? Oh yeah, this is a Clang format thing. The question was, why are there so many spaces here? And in my settings for the remote, I've posted my settings on Piazza, so you're welcome to look at that post and copy them and do what you'd like for yourself. If you use Clang format, it's just another extension that you install. And then if you go and copy my settings from Piazza and paste them here, it should just work out of the box, although post there if it doesn't. And I have a line, which one is it? Maybe align consecutive declarations, that might be it. So basically these declarations are next to each other, so it's going to align them. It makes it a lot easier to read, I think. When you sort of know that the types are all here, the names are all here, I think it's a lot cleaner. And this is totally fine by the style guide, so you're good to go. And it's happening automatically when I save. So like actually lining this stuff up, with spaces is real pain. This is a much easier way to do it. Okay, so here we are. Let's see. I actually don't want to get into detail about I don't want to get into detail about make errors because you're not going to have to do this kind of thing for a while. No rule to make target student.cpp. Oh, I think student.cpp wasn't saved, so it didn't exist. That was a problem there. But you shouldn't have issues like that for the time being. Let's run the next test. See, all this from one test, right? I mean, how many errors have we come across already? If I sort of like banging out a bunch more code, it's going to be bad shape. Okay, so this is from unit test driver. And the issue is undefined reference. So I should clarify. So the driver file calls your tests one by one. And the way the driver works is that an executable is built with all of your tests available. And then that executable is called one time for each test. So in this case, so each time that your unit test runs, it's going to run with a different test being run. So the test that's being run in this case was a constructor test, which is this one, right? We only have one. And the issue here is undefined reference. So this is actually a linking error. And the issue is that, oh, and you'll notice it says linker command failed with exit code 1. So the issue with linking, again, when you compile, the .h file is put into the .cpp file, all the syntax is checked, the types are checked, et cetera, but there's actually no communication between the fact that there is a constructor of the student class named student and the actual implementation of the function that is a constructor. In linking, those things are compiled separately, basically. And then in the linking step is when you actually call this here, the student constructor is called, then you have to go find the definition. And so what this error is saying is, I can't find the definition. And that's because we don't have any student constructor implemented. So let's do that. So let's say, let's just say it's empty for now. Question, good one. Just to make sure you don't have to compile unit tests, right? And it runs automatically when you save and compile the others. You don't have to actually compile anything at all. Student tests or unit tests will run make for you. That's part of its job. So once you hit the play button, it does everything you would normally do when you would type Clang++, and then when you'd run your code. So you just have to hit the button, and then it does all the rest. Error: C++ requires a type specifier for all declarations. Now this is sort of a tricky error because the compiler doesn't understand what we're trying to do. We're trying to write a function definition for the student constructor. However, constructors don't have return types. What C++, what the compiler thinks or what Clang++ thinks we're doing is we're trying to define a regular function here, So that's not what we want. So remember that all of the definitions for the declared functions of a class have to be scoped with in this way. So this is the thing to remember there. And then let's run our next test. Again, one test. I mean, how many bugs have we had? It's just crazy. But you know, the more that we can sort of hammer out all this little stuff at the beginning, then we're going to be, you know, really off to the races. If you write like 30 lines of code and then you have to do this and then there are bugs, oh yeah, you just forget about it. Anyway, use of undeclared identifier student. Well, we should know what this means. Anyone want to post in the chat what's going wrong here? What's missing? Any ideas? Or you can say it if you don't want to write in the chat. Anybody? Take a look. Use of undeclared identifier student. Yes, pound include, exactly. If this pound include is not here, when the compiler goes to compile, it doesn't see that there's a student class. So it doesn't exist. Undeclared identifier. Okay, perfect. Let's keep going. Oh, and when I work, I generally will hide the, I guess we'll have this one. Anyway, error, use of undeclared identifier, std : : Oh, that's different. What's wrong here? So it's a similar situation, but it's with the string library. Okay. Oh, all right. Fantastic. Finally worked. So now we know that the constructor works. We know that there are no memory leaks if I do something silly like this. And I don't delete this. This is allocating 10 integers on the heap, but it's not doing anything with the, it's not cleaning up after itself. And I try to run this, it fails. So this is the output from Valgrind, which has the, let me expand my window a little bit. So there's memory leak. So this is another very kind of typical thing that you'll see. It's from the error result of memcheck, which is run by Valgrind. So again, Valgrind is being run automatically by your code. Just to sort of demonstrate like what I would have to do if I was doing this separately. Let's show you here. Would be this. Okay. Great. So then I would need to write clang. I have to do this. And then I have to do this. And then I have to do this. Right. And one of the reasons about why I built this testing framework is this is something which is very easy to overlook. And when you don't catch the memory leaks and errors early, they can sort of build and build and build. And then it can be extremely hard to identify where the errors are coming from. So the goal here is that if you're running tests early and often, you'll be able to catch these things quickly. And then you can take care of them in a way that is sensible, right? Rather than sort of writing a whole block of code and then having a big mess of a problem. And again, instead of having to do those 3 separate things, and then let's say you navigate around the shell and come back so you can't just hit up all the time, you just have to hit the button. And all of that happens at once. So that's the idea here. Right, and again, the issue here was that we did something silly. So then we go back here, we run our test. Great. So in other words, I'm also demonstrating that a simple declaration of the object not only tests the constructor, but it also actually is testing the destructor, making sure that any heap allocated memory has been freed from the class. So if we did have, let's say hypothetically, integers on the heap, and let's just say, oh, why don't we have some kind of how about an array of courses? And let's just assume for the sake of argument that a student could only ever take 100 courses in their life. Right? So we'll do this. And again, if we run this, we can see that we have memory leak. When you're looking at the output from Valgrind, it'll say in use at exit. The 72,000 error is not actually a bug. That's a long story about that, but it's basically the way that the operating system is configured, or it has a bug with Valgrind that it just does that. However, you'll see here 6 Alex 4 frees. So not all the memory that we allocated has been freed, right? So then we need our destructor. And then here, remember, here, now. What's wrong here? Definition of implicitly declared destructor. Implicitly declared. Why is it implicitly declared? Let's go here. What have we done wrong? Any ideas? I've got all the stuff. This is right. This is right. It's a very common issue, by the way. Any thoughts? Nobody? Come on, somebody. I forgot to save. I forgot to save student.h. So the destructor didn't actually exist because it wasn't saved. Always save your code. Save, save, save. Very common issue. Okay, great. And our memory leak is gone. So when it comes to bugs that often cause the most pain and difficulty, the ones we had to set up were relatively straightforward. Having some rough idea about when you see a linking error, what that means, that you can't find a definition of a function that's been declared in the class, for instance. But a very common thing that happens is that variables are uninitialized and then they're used. So let's say, for instance, we have a getName function, which that returns a string, okay? And we'll mark it as const because this indicates that this getName function will not at all affect any of the private member variables of the class. That's all that means. And we can get rid of that. Okay, so let's go here. One thing that's often sort of tricky at the beginning is that the return type is not scoped like the function name is here. Okay. All right, so we just return name, remembering that this is name. Okay, and yeah, so let's see what happens here. Out of line definition of getName does not match any declaration in So what is this? So the issue here, member declaration does not match because it is const qualified. So the compiler is telling us that this is const, but this is not. Also has to be the same. And one of the reasons for this, I mean, it just doesn't match. Question, is const required? Would it make a difference if we didn't include it? No, it is not required. However, any function that does not affect the private member variables or the state of a class object should be marked as const. Technically, the code will work just fine. The issue is that it's a couple things. One, it's very tricky maybe at the beginning to wrap your head around the syntax of this, why it's here. When the errors come up associated with it, they can be like mind-bendingly annoying. But the thing is, whenever you see a function that's marked as const, you just understand that it will not affect the state of your program, or not the state of your program, but the state of your class object at all. So there's kind of a certainty you have about it that this function has sort of read-only permissions into the class. So that's why it's used, and you should use it. And I believe all of the appropriate functions that should be constant in your homework are. So you'll see in the homework, at the beginning, we're kind of giving it to you, but eventually you'll want to design for this yourself. And, frankly, it'll be one of those things that TAs take off a couple points for. It won't ruin your project, but yeah. So you don't need it, but you need it at the same time. Okay. Right. So let's see. Okay, what happens here? So we fixed that issue. It seems to work. Oh, well, we didn't actually call the, so let's do get name. Another nice thing about the unit testing framework is you can either run all of your tests at once, or you can just run them individually. And it's kind of nice to be able, the first time you have to run it here. I don't know why that happens, but, and then we want s.get name. And let's, I don't know, print this to the terminal. Perfect. Okay, so run our test. Oh, that button's not working. That's weird. If the button, you click it and nothing happens, run it over here. I'm gonna have to look into that. I don't know what's going on. So this seems to work just fine. However, there's actually an issue here. And let's say we do, and so this is one of the most difficult things to deal with. Even if you have a test like this, that's not good enough. So the next sort of thing I want to bring up is your tests. When you're writing unit tests, you want to be very clear about what you're testing and how you're testing it and why. So in this case, just declaring a student a one-line test is not bad for a very simple test of the constructor, right? But we'd probably want to write a few more tests somehow. I don't know, we do something with the name and the age or something like that. Anyway, but in terms of getting a name, we're just printing it here. So we're not checking that the name is what we expect it to be or anything else like that. And in this case, you'll notice that the constructor does not initialize this name with any value. So let's say we had some set name, which updates the name of the person. Oops. Actually, that's good. We'll see what happens. So we'll say, or how about we do this? So this add name function is going to add the name that you provide to the name that exists. Okay. This is sort of a contrived example, but that's the idea. So, and then let's say this takes a parameter. Oops. Okay. And then we do this, right? So let's try to run our test and see what happens. And then let's do this. Too many arguments to function. So what's going on here? Here, I've got expected 0, have 1, s.add name. Note add name declared here, std string add name, student.age 11. There's no parameter. Very common kind of bug. And I mean, to be honest, I'm introducing these on purpose. but I'm hoping that it's helping. So let's run again. So the test failed and nothing printed. Well, that's not very helpful. And this is the point I'm getting at. So why is this test failing? What is going on? I have no idea. And these kinds of bugs come from uninitialized variables. And this is probably, I would say 7 out of 10 bugs that are really sort of head scratching and make no sense and are difficult to debug are ones where the variables that you have are not initialized. And it's so easy to overlook. And then when you're running your tests, you have no information. There's just nothing. Nothing was printed on std error. Nothing was printed on std out. Oh, sorry, a question. I'm seeing no such file or directory for a.out. Do we need to compile? You do not need to compile. The program will compile for you. If it says in your make file, do you have a make file here, Valerie?
Yeah, I have the homework open, not the lab.
I see. But you're using the starter code?
Yeah.
Okay, let me check something quickly. I can do this here. That's fine. So I'm guessing the code didn't compile. Did it compile?
Yeah, I would think. I mean, I ran. What's funny is it was running okay. I was kind of following along as far as testing, and then it wouldn't save, so I just quit and restarted VS Code. And then when I went to run again, I got that error. So I didn't have it before.
It's just saying no a.out.
Yeah, let me run this again.
I'm guessing.
Oh, now it's good. I don't know. Okay, it's gone.
Sure.
Thanks.
Okay. Right. Okay. So we keep going here, right? So uninitialized variables, big bad problem. The compiler doesn't catch it, and it's very difficult to spot once you've done this. So one of my major suggestions to you is that each function that is a constructor should initialize all the variables of your class. Even if there's no name provided, put some placeholder, something, because later on, if you try to use those variables and they're not initialized, stuff like this happens. So in other words, here, what's going on is the add name function does name plus equals s, but name isn't anything. It doesn't exist. And we didn't catch this bug when we did this sort of stupid test of get name, but here it's just not going to work. So we must initialize our variables. So this is something that, gosh, if I had known from the beginning what was going on, who knows how long it would have taken to figure it out. And this is a very common bug, happens all the time. And please write functions to initialize. If you have multiple constructors, maybe they all do similar things to initialize something. So you could create a private member function called the initializer or something like that. And you could call that instead. And then that way, you know that all the constructors are going to at least initialize the variables. Do not make this mistake. You're welcome, Valerie. Bye-bye. Yes, all the variables in the constructor should be initialized in the constructor. Again, if you want to, have some private member function that's, I don't know, called void init, then you could totally do the initialization here, and in the student, you would just call it init, right? This is totally fine as well. So we'll have something here. Okay. And then we'll do something like, I don't know, name equals, let's do an empty string. And then what else do we have? Birthday, GPA, courses. Birthday, GPA, let's just say 0, or even better, we could say -1. This isn't possible in normal terms. So having a negative value is kind of nice in terms of knowing that it's, if we put 0 there, that could actually be a GPA. And then, so courses name, birthday, GPA. So we've initialized all our variables here. This is great. And here in the destructor, we're deleting courses. And here we've got that. So for a second constructor, let's say we wanted to write a constructor that took a string that was the name, let's say, right? So in this case, and then we could say name equals n, right? Oops. Great. So here we could say name equals n. You could also refactor this init to take a name and then say name equals n. And then from here, you would say this. And then here, you would have that. Also totally fine. Both methods work, but this way the constructors are sort of cleanly just calling this init function, and they're basically using the same code. Totally fine. But the key point here again is that our, let's see if we have any other bugs. Too many arguments to function. Expected 0, have 1. Note, init declared here, student.h 515, declared with no arguments. Student.h line 5, and this is the 15th character, right? So if we count, wait, that's not right. 15, sorry, 15th line. Where is it? 15th line, 5th character, right? So in the 15th line here, 1, 2, 3, 4, 5, basically it's just the start here. But what do we need to do? This takes now a string. Okay. And I would say around this point, maybe you want to start throwing in a little bit of documentation. You're going to have to do this anyway. It's kind of not always the most pleasant thing to do, but once you start having a reasonable amount of stuff here, it can be useful to have some documentation. So first of all, let's run this. And we've got a bug still. What's our problem? Add name. Initialized our name with this. Let's try to print the name here just for debugging. And then what we can also do, no member name cout. We need to include iostream here. Oops. Great. All right, run it again. Still don't know what's going on. Let's go back. So when you find bugs, you don't know what's going on, why there's a bug, something failed, but let's comment out functions here and see where things break. Okay, so it broke in the add name function, and we have something. Do we need to save this? Takes a string. So notice this is slated to return something, but it's not. So actually the variable we had earlier might not have been the uninitialized variable. No, still going wrong. Return type out of line definition is not match. Okay, so when we see bugs like this, return type of out-of-line definition of student add name differs from that in the declaration. This is very helpful. The definition, again, is here. The declaration is here. So here, this should be void. Okay. Great. So I wonder if we take away this nice initialization of the name. Let's say there. Let's see what happens when we run this. Because this was supposed to, I was assuming this would bug before, but oh, it doesn't. Wow. Wow. Yeah, so this is like, this is still not catching it, and it's bad, bad, bad. Let's do this. See what happens. I'm still passing. Oh boy. Yeah, see? So this is the kind of thing where uninitialized variables, especially when you're using pointers, they can cause real headaches. So if we have, let's take for instance with the courses, and let's put our name back, and let's say courses does not get initialized. So courses is a pointer to presumably an array of strings, where each string represents the name of a course. That's the idea. And if we say oh no, we don't need to go into details. The idea is uninitialized variable access is bad, bad, bad. It's easy to miss bugs that are caused by uninitialized variables. Sometimes it'll work, sometimes it won't. It's technically what's called undefined behavior. So in this case, the name is getting added and it's working. Oh, did we print the name? Oh yeah, so in this case, the test is passing, but I'm not seeing any information. If you want to force information to be printed, even though a test is passing, you can use assert and then assert something that's false. And this is something I wanted to get to go over as well. Assert is really your friend when it comes to writing tests. A test will pass if it does nothing, right? So a test will pass as long as it finishes, the test passes. But using asserts are really useful tools for you. Generally, you don't use an assert in this way, but we're just trying to fail the test automatically. Oh, sorry, it includes C assert. Okay, assertion 1 = 0 failed, and it printed Matt. So actually, even though we did a plus equals, it still worked. So there was nothing to start here. Oh, wait a minute. We fixed that. Let's keep it broken. Yeah, still working. Anyway, so you'll see uninitialized variables, bad news. Please initialize all your variables properly. Again, particularly with pointers is when you get real trouble, because you'll have declared some pointer, and then somewhere in the body of your code, you'll assume that it points somewhere. So initializing it at the beginning of your program is important, because if you try to get the data from somewhere that doesn't actually exist, you're in trouble. Okay. All right. So normally, let's see, let's forget about that function, because I don't think it really does anything anyway. So let's have a set name. This is not const. Oh, sorry. This is going to be void. Returns void, takes a name. Oh, and we need this in the header file. The thing is here. Right. Takes a string. Oops. Oh. Great. And we'll say name equals n. Great. So if we're testing our get name and set name, What I would do for get name, let's assume that we had before where we're going to initialize a default student with an empty string. The way I would test this function is not to do a cout, but to do an assert. s.getName is the empty string. Because this is, we're asserting the condition that we expect to be true. And if this does not happen, then the test will fail. Again, why is it not running when it is running when I do this one? A redefinition of get name test. You can only, each test has to be distinctly named. Oh, weird. I will have to fix that. Okay, so this passes. This is a much better test of get name than the previous one. The previous one, you'd have to actually look and see if it's what you expect. With assert, the test will just fail if it's wrong. So as long as you format your expected value correctly, then you'll be in good shape. For the set name test, we can do s.setName at r, or maybe we'll do a full name, Russell, assert s.getName equals, and then I'll copy this. Probably even better idea would be a name. And I know this seems sort of silly, but actually it, in the long run, makes life easier in terms of using the variable here. I'm much less, especially if I write this out, it's awful. If I want to change it later, I only have to change it in one place. A much cleaner way to do it. So we're asserting that the name we get back is the name we set. And you'll notice here that in the setting the name test, we are using, oh man, oh, looks like there are two of these now. Let's run all our tests. So it looks like, okay. Another bug I need to fix. I had the two test names before, and now one's still hanging around. I'll bet if I reinitialize the workspace, it'll go away. Anyway, so you'll notice that I'm using the getName function in the setName test, but this is totally okay. The key thing for writing these tests is just that they're precise in their scope, as precise as you can be, so that when you find an error, you're pretty sure it came from setName. We have a test for getName. We basically trust that test. And you know, this function is relatively trivial, right? It's just, but having a test for it is good. Okay. We could also, yeah. Okay. Let's see. So the key thing to remember is writing a little code, writing a test, running the tests until you figure out all the errors, and then writing more code. Again, at this point, some documentation would be helpful. And the main reason it'll be helpful is for yourself later. When you're looking back at your functions and it's like, oh, what does that do? What is it called? Does it have any unintended side effects I wasn't thinking about? You really want to be able to document all of that. Also, once you write the first sort of function contract, right? Where you've got the name, right? And the sort of purpose and parameters, returns, something like this. As the student object, and this is kind of straightforward. String, which represents name of the student, and then returns none. So something like this, you could even format this nicely like that. Pretty clean, right? And then you could just copy and paste this and use it over again, right? And easy. So once you write the first one, it's the hardest. And then all the rest of them, it's pretty straightforward. Documenting is really useful way to avoid running into problems where, you know, you've got some function, let's say, that does something that's not necessarily obvious by the name of the function, or even by the purpose of the function. You might update some member variable somehow, it's a really good idea in those cases to add effects. And then this is like, we'll sort of detail exactly what it's doing. That's sort of not necessarily obvious. This is a good thing to do. Very, very useful for yourself when you come back later to look. Okay, let's see if I have any other. So yeah, planning out your code, writing less than or equal to 10 lines, really, honestly. Remember how many bugs we had at the beginning, just based off that one single, 5 or 6 lines of code, just especially at the beginning. But really, you want to run tests as often as possible. Every time you start to write a new function, write a test for it and run it. You'll catch bugs quickly that way, hopefully minimize the total amount of trouble that you have to deal with. Yeah, and then let's see, there are other things. We went over a bunch of basic syntax errors. We went over a little bit about compilation linking. We had most of, lots of common bugs. Public and private issues. We didn't really get into pointer stuff at all. But that's perhaps a conversation for another day. Let's see, what else? Oh, another thing to think about when you're writing code that's going to be easily debuggable is making your code as modular as possible. Don't write functions that are really long. In general, it's not a good idea. If I think the course style guide says 20 lines for a function, most of the time you can get away with far fewer, even on, these are sort of very straightforward, but even with more non-trivial functions, if you find something approaching 10 lines, it might be best to break it off into its own private function for you to use, especially if you're going to be using it multiple times. If you find yourself writing the same block of code that's 4, 5, 6 lines long, put that out into a function and make life easy for yourself. And then write tests for that function, so you know that function works. Then when you use it elsewhere, you can be certain it works. When bugs in that other function show up. Let's see, other things I mentioned. Yeah, I think that's sort of the main ideas I wanted to get across today. So, hopefully this workflow should make that pretty easy, right? That's the idea. That's the idea behind the unit testing framework, that you can be just very quickly running your tests and running one test at a time, running multiple tests. Again, for some reason, this is just not working here, but you can run single tests this way. You can run block tests this way. You can actually, I think it's like this. So if you have a test group, this actually, you can run a group of tests. So that will allow you, if you've got like another one. Okay, and then we run this. Oh, what is going on? I guess we do that. So undeclared identifier, some test. What's going on there? Oh, interesting. Oh, gosh. All right, so forget about the test groups. Must be some bug with that. Well, this will work. Good. So the other main thing, right, was the assert. Using assert in your tests. You know some condition. You want to assert that it's true or assert that something's false. So that's very, very important, right? So if you have some, get size or something that returns, oh, well, student, it wouldn't really matter. But, if you've got some container like an array list where the size is changing, you have a function that gets the size, writing a test and then asserting that the size is 0 when you start, asserting that after you add an element, the size is 1, you take one away, the size is 0, asserting elements are in the correct spots, all these kinds of things. That's how you want to approach it. Oh, question. What factors should be considered when coming up with useful tests for a program? So, when you're coming up with the test, you're usually testing a function, right? So you have some function of your class, and you're trying to ensure that that function does what you expect. So any test for a function for your class is going to try to call that function and test that the state of your member object is as you would expect it to be after the function has been called, right? So again, in the set name or get name, in get name, we're asserting that the name that we get is what we expect it to be. In set name, we're asserting that the name that is updated is what we expect it to be, right? So we're simply writing code that uses these functions and then using assert statements to assert that the conditions specified by those functions exist like we think they do. And that's the idea. So any useful test will do that. We'll call the function in question and then assert that the state of the object is as you expect. Sometimes things are not so obvious, like when you have something that doesn't affect the state of your function, like when you're thinking about things like the big three, you know, you've got to be making sure that you're making a deep copy of the data from one into the other. Or if you're testing, again, and to reiterate, any test function is good if it is explicitly calling the function in question and asserting that the state of the object is as it's expected to be after that function was run. So if that function updates some variable, test that it's updated. If that function inserts an element, make sure it's in the right place, make sure the sizes of the structure is what you expect it to be, et cetera, et cetera. So that's the idea. Does that help, Rafid? Good? Not good? Yes. Okay, great. Again, this is your number one, assert is your number one tool here. Normally, I would imagine if you're writing tests, well, never mind. That's neither here nor there. Yeah, let me see. I don't think, I think that was about everything I had listed for. So we're at 4:25. I think it's right about a good time to stop. Does anyone have any last questions before we conclude?
Yeah, so for the unit test functions that we write in the .h file, how much comments should we make about those functions?
You should have some comment. Again, the hardest part of this is just getting the syntax of this, right?
So we will still follow the same guidelines.
Yeah,
guidelines like name.
All of these are going to return void.
Okay.
And none of them will have any like effects, like I mentioned before, where you might have something here. They also have no parameters. So, you know, something like this is fine. And in some sense, it might be trivial, but so in this case, we would say initialize the default constructor or initialize the something like this, right? Yeah, they don't have to be super long or anything. But, you know, for instance, you might have 3 or 4 tests for a constructor or something, and you might not want to fit all of the, like this doesn't say default constructor test, right? It just says constructor test. You know, I can do this. But, you know, it can be useful to have a purpose. So I would comment them. Yeah. Okay.
Okay, thank you.
Question about the no play buttons. Okay, well, why don't I conclude this now, and then Rafid, I can I'll stop the recording, and then we can look at your stuff. Okay. All right. Stop recording.